Okay, so hello and welcome to the continued coverage of the ongoing walkthrough series. And in this episode, we are looking at the Python solution to question 3 of May-June 2025, variant 4.1. So this is the paper, just to show you the paper that we're working with. This is the paper, in case you want to follow along with the video. Okay, so let's just scroll back all the way back to the question here. Okay, so it says that a program stores data in a binary tree that is designed using object-oriented programming. Let me quickly point out that I have a video here on my channel where I go in detail covering the various data structures and algorithms that are required for this particular course. So in one of those videos, I actually cover the binary tree extensively. But maybe for this, for the purpose of this question, just to give you a sort of like an idea of how a binary tree works. Particularly this one. This one is called an in order binary tree because the way it is, the way the data is arranged is that we have a root node. So 30 is the root node right there. Then we have 30 is going to have children, right? 20 and 45. But then what happens is that all the children that are less than 30 are going to be on the left side of the binary tree, and all the children that are greater than 13 in terms of value are going to be on the right side of the family of the binary tree. I was gonna say family tree there. Then so this is true for all the other nodes. So if you go the second level, you see that the values on the left of 20 are less than 20, that is 1, and the values on the right of 20 are greater than 20, which is 21, and it also goes for 45 with 33 and 63 like that. So yeah, that's the essence of the binary tree that we have here. Then these are of course called nodes, is it? And the entire thing is called a tree. So here we are given the class diagram called node, and we are supposed to create a node class, as it were. So whenever you receive a class diagram, you are going to have the fields or the attributes as the first section. Then the second section is going to be any fields that are needed inside of that particular class. So our task here is to create a program code for the node class as well as its constructor. Then since we are using Python, we are going to include attribute declarations using comments. But for this particular one, they weren't really necessary because the code was kind of straightforward, as it were. But still, I did put comments for this one for the nodes so that you can know which is which. But yeah, okay, let's just go ahead and look what we have going on. So here for the class, we have the class declaration from lines 3. So class node, then the constructor. You remember that the constructor in Python is called init, short for initialize. Then of course you can always check out my other videos on the channel where I go in detail covering what you need to know for Python if you are taking this course. So the first argument for any constructor is going to be self and the data variable there. Then we are just initializing the values to data, none and none there for the constructor. Then of course you go ahead and copy this code and paste it inside of your evidence document. Then moving on to item number 2, here it says here write program code for the 3 get methods. So the get methods here, there they are. We have get left, get right, get data, and we are simply returning the node, as it were. Then of course you know what it's supposed to return. If you come back to the class diagram right here, when they say get left, it's going to return the left node, get right is going to return the right node, and get data is going to return the node data. So that's the getters for the particular class. Then for the next question here, it says here we should create the set methods for the particular class. So we have set left, set right for the class. So we can come here and look at the implementation going on from lines 23 to 28. So you can see that we have the set left and the set right methods, set methods rather. Then of course you go ahead and copy this code and paste it inside of the evidence document. Again, there's nothing much going on here. It's just a function header and the return rather the set. We don't need a return for set. We're just setting the left node to the current node that would have been passed when set left is called there. Then let's move on to B. It says here that we should write the main program to declare 5 objects of type node. So we are now making use of our node class and assigning those values. And if you remember, the node class actually is a constructor here, right? So whenever you create a node object, you are going to pass, you are going to make use of the constructor, because remember, a constructor initializes an object. So the way we are going about it is we are going to call our first node, node 1, and we are calling the node class as well as, rather in this instance, we are calling the node constructor. So we are passing the constructor a value of 10. From the node class, we are passing a value of 20, and so forth and so on. Then you would of course go on and copy this code and paste it inside of your evidence document. Again, this one, there's really not much thinking that needs to be done. These are some of the low-hanging fruits that you should be targeting for. Then I should go back to the question here. Then it says here that we are given another class diagram, and we are supposed to declare a class called tree that has those attributes and fields. So you see that we have the node field, and we have the constructor, the get root node, and the insert method. So here we are supposed to just create the class in this constructor and nothing else. So let's go ahead and do that. So we have the class going on from line 48 there, the class tree, right, and the constructor right there. Then we will be done here. It's only 2 marks, so there's really not much that needs to be done. Then of course there's also the get root node function, which we have going on at line 54 and 55. So it's just the function header as well as the return type, or the return, what we are returning from that particular node. Then the method insert takes a node as a parameter and then searches the tree to find the position to insert the new node by checking whether the node's data is less than or greater than the root node's data. Then moving to the left if the data is less, then moving to the right if the data is greater. Then it's going to repeat this process until we find a position where we can put our particular node. So let's say, for instance, we wanted to, if you go back to the class here, to the binary tree, let's say we didn't have 21, right? We just had 30, 20, 45, 33, 63, and 1 here. Essentially what it's saying that we need to compare if 21 is greater than 30, right? So we know that 21 is less than 30, so we already know that we are going to set it to the left. So we move down to the left side and look at 20 and check to see if 21 is greater than 20 or is less than 20. So it's greater than 20, so it means we need to set it to the right, is it? And when we finally arrive at this position, that's where we're going to set 21. So essentially that's what they are saying with insert. We just want to write a program code that's going to allow us to insert new nodes into our binary tree, and we have to compare the current node value with the one that we want to insert. So you see that you need to do a little bit of planning before you attempt this one, because it's worth 6 marks. Okay, I'm going to zoom in so that you guys can see the code a bit better. Alright, so for the code, for the insert, you see that we have the function definition there on line 58. Then we are taking the first node and setting it as the current. Then essentially we just have a loop that's going to run, and we are going to break out of that loop if we satisfy either one of the conditions whereby we have the node being greater than and we find a position for it to be set, is it? So we are saying, well, true. So if we do that, it's essentially going to mean that our loop is just going to run for however long we need it to run, is it? So here we are checking to see if the node, the current node, and we get the data, and check to see if it is less than the current dot get data, is it? Remember, the first node we set it as current right here. So we're just comparing to see that if the node that we want to add is less than the node that is the root node. So if that's the case, it means that we are going to set it to the left because it's less than. Because remember, in a binary tree, all the values that are less than the root node, they are set to the left. So we would go ahead and set it to the left. Then if only if the current node is none, meaning to say if there's nothing there, then of course we'll break out of the loop. Then otherwise we are just going to continue and move on to the next node. If should there be a value there, right, we're just going to move on to the next and compare set current. That is the node that is a level down, is it? That's what we're going to set as the current, then do the comparison again one more time. Because remember, this is an infinite loop. We only break until we satisfy either one of these conditions here. Then for this else clause, we're just comparing to see, so if it is not less, it means it's greater than, so we're just moving to the right and basically just repeating the process of checking to see if that node is greater than the node that is inside of current until we find a place for us to set it right there. Then we break out of the loop. So this is what the code is doing. Then, of course, you go ahead and copy this code and paste it inside of your evidence document. Let me just zoom out here a little bit. It's too close to the screen. So yeah, moving on to the next part. Here we are supposed to write a recursive procedure called output in order that outputs the data stored in the binary tree in ascending numerical order. Then the procedure takes a node object as a parameter and then checks if the node is now. If there is a left node, the function calls itself with the left node. Then it outputs the data of the current node, checks if the right node is now. If there is a right node, the function calls itself with the right node, is it? So basically, that's the whole idea of recursion. Again, you can always check out my video on data structures and algorithms for 9618, and you actually see that you actually find one in which we go through recursion in more detail. So let's go ahead and look at the implementation. It's not the code is not even that long because it's a recursive function, right? So essentially, the function is just going to call itself. If the node is not now, then we are going to output the left node, right? Then we print the data. Then we are also going to get the right data and output it, is it? So basically, we are just jumping from one branch to the next and then outputting the data as it were. Then, of course, you go ahead and copy the code and paste it inside of your evidence document. Then item E, item 1 here says write program code to extend the main program to create a new object of type tree with the node containing the data 10 as the first node. Then insert the nodes with the values 25, 15, and 7 into the tree in the order given. Call output or in order with the tree's root node as a parameter. So let's go ahead and take a look at that. So my main program, my main function is up here. So this is what they're saying, that we are calling tree and passing node 1 as the root node, is it? Or as the first node, as it were. Then we insert the other nodes, that is nodes 2 to 5. After which we are supposed to call output in order, right? So remember, tree output in order is inside of the tree class, right? And since we created a tree object, we can just use the dot selector to call output in order. Then we can take that tree object and get the root node as the first. Then finally, we are supposed to test our program and take a screenshot of the output. So we can come here and let me just open my console so that you can see. There's nothing in the console there, so let me just shrink this a bit down. Then I'm just going to hit on the play button, and you actually see that this is the output from what? From our file right there, question 3J25Pi. So, of course, you'd go ahead and take a screenshot of this by holding Windows Shift and S and taking a screenshot of a controlled area. Then you can go ahead and paste this inside of your evidence document. So, yeah, I think that's just about it for this video. I'll see you in the next one.